Well, welcome to the lab where we're going to build an inverting op amp in Multisim. What we show here is an inverting, and typically we have the feedback resistor and the input resistor going into the non-inverting input and our signal going into the non-inverting input. And our formula for the gain, AV, voltage gain, is the feedback resistor divided by the input resistor. So 10 divided by 1, so we should get a gain of 10. This minus just reminds me that it's going to be inverted. Gain does not have minus values, but that just reminds me that it's going to be inverted. Okay, I have Multisim open. This is my copy, but the one on VMware should be very similar. And let's start adding components. So we could select any of these right now. And let me go ahead and move this over here so we can see it. And let's go to power sources and let's go VCC. Okay, that'll be our positive. And let's grab VEE, that's going to be our negative. Okay, and we're going to need a ground. Alright, so let's go to resistors. So we're going to go to basic resistors. So let's grab a 1K. Let's go down and grab a 10K. Alright, so let's go to analog and let's grab a op amp. So we got op amp, let's just grab a 741. Okay, and we need, let's go back to our sources and we're going to need a signal voltage source. So let's get AC voltage. Yeah. And that should allow us to input in a peak value. Yes, it does. And I'm going to go ahead and give you this as a basic file so you can start. Don't need to chase the components. Okay, let's get started building our op amp here. So let's go to View and let's do a zoom area. So let's go ahead and window this up so we have bigger picture. So let's go ahead, first thing let's do, this is the non-inverting on top. So let's invert that by flipping vertically. And now we have it as we see it with the inverting input. That just makes it a lot easier to utilize what we have. So let's go VEE, which is going to be positive voltage. And let's go VCC. Let's flip that one vertically so it connects right to our 7. And let's drag it down, make sure we have it. And let's change the VEE to -12. And let's change our positive to +12. Okay, good. So we're going to have a 10K as our feedback resistor. We're going to have a 1K as, oops, grab the title. Let's try again. There we go. And we're going to need a ground here on our signal. Okay, so let's go ahead and let's move all this. So I'm going to click and window it and let's move it over here so we got a room. Alrighty, so this guy is going to come around and go to our input, and this one's going to go here. And we're going to copy our ground for our input. let's grab this, our input signal, and that looks good. We don't need our compensation over here. Let's move this down over here. Good. And let's call that good. Okay, I forgot to tie in our feedback resistor, so let's move this over a little bit. Let's move this over so it looks a little better. There we go. So we're going to grab a Tektronix scope, the same one that we'd use in the lab. And it has very similar controls as a real one. At a ground, and we're going to go ahead and take this as our output, and we're going to do this one as our input. So we're going to have yellow as our output channel. Let's move this down so it doesn't get good. So let's go ahead and turn our circuit on. Well, first off, let's save it because we're going to utilize this. I would save all of these, and because we're going to be using the basic op-amp circuit, so save it so you have all the power and everything all connected. So let's go ahead and turn it on. Open our Tektronix scope, turn it on. And let's turn our yellow down a little bit, so spread it out. Good. So let's turn our blue on. And we have 10 volts, 1 volt, and it's inverted. So let's go ahead, I'm going to make that a little bigger. I'm going to take as much, there we go. And they look identical. Okay. So let's move this down back a little bit. So they look the same size, but we have 10 times the gain. So let's go to measure. And we're going to go to channel 1, and we're going to do peak to peak. And we're going to go back, channel 2. Oops, channel 2. And we're going to go peak to peak. And I went right past it. Let's try again. One more. There we go. And go back. So now if we look at our measure, and there's a couple ways we could do this. And let's go to single so we could see it. And we have 20 volts peak, 2 volts peak to peak on the end. So we have 20 divided by 2 is a gain of 10. Perfect. Multisim will allow me to expand our oscilloscope window. So I went ahead and used my snipping tool and pulled this out. So you can also use that snipping tool in order to drop this into the lab, and you have everything you need. On the bottom we got 5 volts per channel, 20 volts peak to peak, and we could count our boxes, 1, 2, 3, 4, our graticals, and 4 times 5 is 20, and 0.5 comes out to 2 volts. Okay, and as you see that it is 180 out of phase, being an inverting op-amp, so this is correct. Okay, here we have our non-inverting op-amp circuit, and you can see that our signal voltage is going into the non-inverting side, and again we still have our feedback and input resistor going into the inverting side. So our formula is for the gain RF over RN plus 1. So if we go through and do the math, this should be a gain of 11. Okay, so let's go ahead and save this so we can use it in the future. And let's get rid of our oscilloscope. And let's turn off our... Alrighty, so let's go ahead and convert this to non-inverting, which means we need to take our signal. I'm going to delete that. And let's just take this whole thing. Don't want the resistor, but I'll fix that. Okay. And this is non-inverting, so we're going to move our resistor over here. And we're going to take our non-inverting input and connect it to our signal generator. And I believe that's it. So let's save that as something else. We'll call it Amp 2. And let's open up our scope again. Turn the power on. Okay, so let's do the simulation on our inverting. So let's start the simulation. Let's turn the scope back on. Let's go ahead and turn off the single sweep for a second. That's good enough. And what we have now is a signal that is in sync. And if we do the math, we have almost 22 divided by 2, which is a gain of 11, which matches our non-inverting amplifier. Here's an expanded view of our oscilloscope output, and you see that it's in sync, and we have a gain 22 divided by 2 should be a gain of 11. So it's perfect.